Hello, today we're going to talk about a crash course in chemistry. We're going to start off with a few variables. So we have S for entropy, lowercase k for the rate constant, Kc for the equilibrium rate constant, Kp for the pressure constant, and delta G and delta G standard for the Gibbs free energy. So let's start off with entropy. So entropy is just the activation energy over temperature, and we can relate this to the rate constant given the Arrhenius equation, where it's AE to the power of the activation energy over temperature times 1 over R. So then we can just substitute the AE over T for S to give us K equals AE to the power of minus S over R. And then we can relate the rate constant to the ratio of rate constants, which equals the equilibrium rate constant Kc. So given a reaction, AA plus BB will give us C and times DD. So we have the ratio of rate constants given this function equals our equilibrium constant. So having that said, we can also apply that to pressure, where we have the equilibrium constant with the pressure value of C to the power of C and so on and so forth times 1 over RT, which we get the P of C times the P of D over the P of A times the P of B times 1 over RT to the change in exponents. So we have Kc, which is the rate constant, times Kp, which is the pressure constant, given to us by the ratio of this function right here, over RT times delta N. Delta N is just a simple saying for the change in powers. We can flip this around and make Kp equals Kc times RT to the delta N. And then all related back to entropy, we can say that entropy equals work, and work equals TdS, where it's temperature times the change in entropy. We also can state that W, which is work, equals energy, and can be stated as delta H. Therefore, when we use Gibbs free energy, we can state that delta G equals delta H minus T times delta S. Given that, we can plug in the standard Gibbs free energy. So we have delta G minus delta G standard equals N RT to delta P over P. With that, we can state that delta G can equal delta G standard plus nRT to the natural log of P. And we can also state, thanks to this ratio, state that P is equivalent to the quotient, which is a quotient of this equation right here. Therefore, we can state that delta G equals delta G standard plus nRT times the natural log of Q. Then we can go even further to solve exactly what delta G standard is. We can assume that delta G and the constant n equals 0, which gives us this equation. 0 equals delta G standard times RT ln of K, where K is a direct relation to Q. And then we can give us delta G standard equals minus RT ln of K. This simplifies what standard is. There is no variable or constant to consider n. And that's that.